In this video, we're going to be talking about transcription and translation. This transcription and translation is a process that uses DNA to code for various proteins. So we know that DNA is in the form of a double helix, and the double helix is held together by the hydrogen bonds between nitrogenous bases. So what's going to happen here is we need to unzip this DNA to get to the nitrogenous bases inside. So today in class we learned of an enzyme called helicase. And what helicase is going to do, it's going to travel down the nucleic acid and open it up at a specific sequence that codes for a gene that is required, or a protein that is required. So when helicase gets done with this, what's going to happen is the DNA molecule now will look like this. With the hydrogen bonds broken, the structure is now unzipped, and the bases are now available for RNA polymerase to come in. To make the messenger RNA, which is the copy of this sequence. And then once the messenger RNA is made, the messenger RNA will leave the nucleus, go to the cytoplasm, where it's translated to make protein. Now just remember that RNA has the same nitrogenous bases as DNA, except RNA has uracil in place of thymine. RNA does not have the base thymine. So let's see how this would work. So here we have a double-stranded DNA molecule. Helicase is going to come in, unzip it, break the bonds between these bases. Now we need to make the messenger RNA, so that's where RNA polymerase comes in. So G will go with C. Just going to change that to red. C goes to G. T goes to A, but remember, A would normally go with T if we're making DNA, but we're making RNA, so T goes to U. A goes to U, A goes to U, C, G, G, C, and A. So now, this structure here is our messenger RNA. So the messenger RNA now will detach. The DNA will now zip back up closed, and now we just completed transcription. And remember, transcription happens in the nucleus. So now we got to get this. Now we got to go to the next step, which is translation, which happens in the cytoplasm. So the messenger RNA is going to leave the nucleus and go down to go out to the cytoplasm, where the ribosome takes place or works. So, in purple, let's say green here. I think this is, green. Let's say this green sphere or circle is representing the ribosome. What the ribosome is going to do is it'll read 3 bases at a time. And we call these 3 bases on the messenger RNA, we call them codons. And what the ribosome is going to do is it's going to try and match the codon with the appropriate anticodon. And the anticodon is found on the transfer RNA molecule. So over here, I have what we call transfer RNA molecules. On the top here, this represents the anticodon. Down here in these boxes, that represents the amino acids. And you put numbers in there to represent different amino acids. So what the ribosome is going to do is it's going to try to match the codon of the messenger RNA with the anticodon of the transfer RNA. So CGA is the codon. So the anticodon for CGA, now we have to convert it back. So C goes to G, G goes to C, and A goes to U. So we look over here, look for the anticodon GCU. Where is it? Oh, here it is. So this comes over. So GCU will come over and line up. The anticodon and codon will line up, and then the ribosome moves down next to the next codon. So this codon would be U goes to A, C, which is this one. So this comes over, links up. This ribosome goes down. These two amino acids bond together. The transfer RNA detaches, and then the next transfer RNA molecule comes over, links in. These amino acids link together, forming a chain, and then eventually what we have is a sequence 156, whatever these amino acids might be. So the messenger RNA, the ribosome, is going to read the messenger RNA, match the codon up to the anticodon to put the amino acids in the correct sequence. I know it's a lot to take in. We're going to go over it in class tomorrow also, but if you need to, replay it. But I also want to show you this. This is called a codon chart. We looked at this today in class. So how this works is you need to find the codon to determine the amino acid sequence. There's another different way of doing it. So here's my DNA structure. I know this is DNA because it has T, right? It doesn't have, and it has A's. It doesn't have U's. So what we need to do is convert this to messenger RNA. So C goes to G, T goes to A, G, G, G goes to C, A goes to, right, U, U, G, C. So this is my messenger RNA. And remember, every 3 is a codon, and this is a codon chart. So we go right here. The first codon is GAG. What's the amino acid? We go G, start from the middle and work out. G, A, G, and this is glutamic acid. I'm just going to abbreviate it GLU. Here's the next codon, GCU. G, C, U. Next amino acid is alanine, and they bond together. The next codon here is UGC. Start from the middle. UGC. Next one is cysteine. Okay? So what I want you to do is use this codon chart. I have one in the folder for genetics on Schoology, and tell me what amino acids, the correct amino acid sequence for this DNA structure. We know this is a DNA structure because it has T instead of U. Okay, and then if you need to, watch the video again, and then tomorrow in class we'll go over it.